Right, ladies and gentlemen, fellow engineers, you're welcome to another interesting, amazing webinar by the Nigerian Society of Engineers, London, UK branch. Today we have, as usual, a very, very interesting engineer that's coming to present to us a lifetime of design. That's the title. I'm not going to mention his name yet because he needs to be introduced properly. But before we start, I just want to take you to a couple of protocols. Right? As you know that, when you come in, please mute yourself so that we'll have a very good session today and not disrupt the speaker. If you have any technical problem, please just chat with us on the chat. I have my colleagues in the background that will reply to you instantly and immediately. And as we speak, or as the presenter give his presentation, if you have any burning questions, please put in the chat. And we'll either read it out at the end during the question and answer, or we unmute you and ask you to ask your question. The presentation today is recorded, and we hope we have your permission. We've also sought the permission of the speaker to allow us to record this presentation. But unfortunately, because it's the sensitivity of the work that has been presented, the slides will not be made available to anyone, not even to me. Yeah, so I will be seeing this slide for the first time, and I will not have a copy of it. So please do not request, or if you do request a slide, none will be given to you. But the video that we've recorded, you'll be able to watch that over and over again. So with no further ado, I'm going to do the usual acknowledgement. As you know, we're a branch in the UK, but we have the president of NSE, Engineer Mohammed Babangana, that we'd like to acknowledge. He's not in the room at the moment. Hopefully he will come and join us later. The Executive Council of NSE and all the chairmen and chairperson of NSE hereby present, we acknowledge you. Fellow engineers, associates, architects, we do have some architects in the room, and all the colleagues of our presenter that have joined us today, we welcome all of you to this event. I could see the CEO or the chairman of Varap already, Nigeria already with us here. So thank you, welcome. And today, we are last 2 weeks ago, we had a sponsorship by War Remit, but today War Remit is not sponsoring us, but don't worry, we'll find another sponsor next time. So that's that. I'm I didn't introduce myself. I'm Sunday Popola, currently the chairperson of NSE London UK branch. And this event that we've been doing has been going on for a while. And just a little bit about NSE London branch. We were created or inaugurated 2018 as one of the first 4 branches to be established outside Nigeria. Yeah, and we share engineering knowledge as we'll be sharing today. We're trying to transfer our experience of engineering from diaspora to our colleagues in Nigeria. Hence the reason why we're running this series of engineering webinar. We've had so many of these since inaugurated, and we also do a lot of work in terms of inspiring young students to become an engineer and show them a bit of what STEM is all about, technology and engineering. And we're also trying to give something back home. Sitting here, doing our work, earning our salary is not enough. So we're looking for initiative where we could impact what is going on back at home. So Theo.
Thank you very much, Doctor. My name is Theo Bosun-Odolami, and it's a privilege to be amongst you today as fellow and co-engineers. Just like our doctor has reiterated, NSE London UK branch, we have been at the forefront of putting across the challenges and at the same time the opportunities available to engineers of Nigerian background. Not only impacting their ways of life in diaspora, we are also looking forward to see what we can give back to the country based on our experience and achievements abroad. We endeavor to contribute to the development of a supportive and vibrant engineering community, both within Nigeria and in diaspora. We look forward to enhancing the connectivity between the Nigerian engineers and other professional groups. And that is why we can see that our audience at our webinars have always been cutting across all spectra of professions, as it were, architects, engineers, builders, project managers, even lawyers coming to our webinars to give us insight and insightful sessions. We want to look forward to promoting investment as well in infrastructures that will be fit for purpose in Africa, in Nigeria to be precise, and at the same time in any area or environment we find ourselves. And how do we do this? We want to build a closer and mutually beneficial link with every engineering community, both in Nigeria and in the UK. And that is why we are always having these webinars, cutting across. I mean, with the help of Zoom, we've been able to kind of touch every nook and cranny of the world with our ideas through our webinars. As we always know, the road to prosperity is paved by good engineering solutions. And that is why we are engineers. We provide solutions, and the solutions are there with us. And I'm sure definitely we're going to hear a lot about that today. Over to you, Doctor.
Right, as Theo mentioned, we have mentioned also we organize a series of webinar. Now we call it webinar. Normally it's a seminar that you come into a room and we share knowledge together. We invite a presenter, and as I've said before, we also go into schools to make sure kids know we're trying to encourage them into engineering and science. Because for me, once you capture them right at that age, they're going nowhere. That's how I was captured to be an engineer. It was right from the start. And learning from abroad or from diaspora, as we call it, is one of the main mission of this group, that we want to scan all over the world and we'll see new knowledge, new ideas, new technology, and we'll do our best, new innovation to try and impact those things into our country or into Africa generally. So we're always looking for new things. We've taken skill from South Korea, from Taiwan, and we've tried to make sure, our colleagues back home know what this is all about, so that they could also be able to use those skills as appropriate. Yeah, the Japanese are very good at it. The Chinese are very good at it. They'll come to your country, they'll take loads of pictures of things you're doing, and by the time you know, they've done even better than you. Yeah, and I won't call it stealing, but that's technology transfer, and that's what we would love to continue to do. Theo, the next slide is yours.
Yeah, thank you very much. Thank you very much for that, Doctor. And I think we need to more or less kind of highlight our achievements so far and map them with our promises that we've had since we've been inaugurated. We want to let us know that we've been able to do a lot of webinars on this platform ever since we've had the lockdown. We've had webinars on green energy, the solar energy, solar powered energy. We've had the webinars with our collaborators from Nigeria, representative of the Lagos state government. I'm sure we are aware that we are about to commence a big, iconic structural and infrastructural outlet in Lagos, the 4th mainland bridge. So we've had representative from the Lagos state government giving us an insight on how we can partner on that. We've had webinars on how we can harness our responsibilities and in terms of housing. There was a powerful one given the last time by Dr. Popola on affordable housing using modular structures. And that is why we've opened our doors to every area of professional endeavor for people to know that we're ready to collaborate with other organizations. We're ready to partner with individuals to see how we can push things forward. Doctor mentioned earlier on about technological transfer. We've got a pedigree of established and well-experienced professionals here in the UK and in America. And we want to harness into that and bring it and mentor new and young engineers to come into play, to build capacity for the engineering sector, which is lagging behind in Nigeria at the moment. So it's not a matter of just kind of maybe coming and doing webinars. We want to use this avenue to motivate other people, other children coming on board to have interest in engineering, for transfer technology, for research purposes, innovations, and even skills development. And that's exactly what we stand for. And definitely we have been seeing results in all these areas. And today's webinar is another inroad in achieving our aims and accomplish our achievements. Over to you, Doctor.
Right, as you all know, for us, we believe the only people that can develop Nigeria are the Nigerians themselves, and this is where it starts. Just to introduce some of our members of our executive, we've been around for about 2 years now, so our time is coming to an end of this year. Yeah, so by December, this executive will not be there. Maybe some of them will stay. So we're looking for new people. We don't believe in all this election wasting time. You volunteer yourself. I know NSE may not agree with us, but we volunteer yourself. They'll say, yes, I want to come into this position. And then we have a meeting and we decide who takes what position. Because if you're not ready to spend your time, your effort, even your money, there's no point coming in here and having a position, a name, president or chairman, whatever, and not do anything. You need to be fully committed. So we want people, please tell us, email us, come to us, and we'll sit down and see how you can contribute to this. The other one thing also we do every other week is to celebrate ourselves. And we've been celebrating UK, we've been celebrating ourselves, and this week will not be any different. So I'm going to play a video of us celebrating ourselves. Where is it? Okay, here we are. A video of us celebrating some of our colleagues that have done so well in engineering, just to highlight who they are and what they've achieved. So I hope this works. Most of the time it doesn't work properly with time, but right. So this is it. Thank you very much. Thank you very. Right. Okay. Let me go back to sharing. Right. Okay. Let's go back to sharing. Okay. Go back to sharing. Right. So with that, oops. There's a feedback here. Let me just. Right. Okay. So with that, we're gonna move on to basically letting you know that yes, we do need membership. We want you to come and join us. If you know any engineer that lives in London, Nigeria, or Africa engineer that lives in London and the surrounding of London or Southeast, please get in touch with us. We would love you to contribute to what we are sharing here in this London NSE branch in London. With no further ado, I'm going to ask my colleagues, Engineer Gabriel Ige, to please introduce our presenter for today.
You're muted.
You're muted.
Oh, okay, sorry. Thank you, Dr. Sunday. I'm very proud to introduce my mentor, senior at university many years ago, Albert Williamson-Taylor, renowned civil and structural engineer. He's the co-founder of AKT2, which is a well-known, renowned structural engineering consultancy. He and two friends formed the consultancy in 1995. And since then, they've been fantastically successful, doing projects around the world, including Africa. They've also worked on many iconic buildings, including collaborating with Lord Norman Foster, the famous architect. So, I mean, I could be here all day introducing all Albert's achievements, but I think I'll hand over to Albert to do his presentation. Thank you, Albert.
Thank you very much for the introduction.
While Albert is sharing his slides, I mean, I look at his bio, and I think people need to hear this. Yeah, people have to hear this. He was involved in the Zayed National Museum and Mansour City, both in Abu Dhabi. I'm sure some of you have been to Saudi Arabia and Dubai and all that. Yeah, they're also an advisor on the master planning of this scheme, as well as the Masdar Institute of Science and Technology. More recently, his work on South Bank Tower with KPF and the Google North Bayshore Campus in Mountain View, USA. And before this meeting started, he's also told me some of the amazing building that he's been involved with NEMA organization in Imperial College London. I mean, this is no joke here. We're going to be hearing from one of the most experienced, innovative Nigerian engineer that we've ever seen. So, you know, Albert, I'm really looking forward to this. So please, let's hear from you.
Oh, thank you very much. Thank you very much for the introduction. I'm really pleased to be here, and I'd really like to thank Gabriel for the invitation, and also Dr. Sunday for you guys inviting me to just give you an insight to my career and some of the stuff that's happened. Without further ado, let me just share my screen. So we can get started. It's a privilege actually to talk to you guys, because at the end of the day, I've been involved in engineering now for about best part of 38 years. And in that period, it's been a lot of ups and downs, but at the same time, I hope everybody can see my screen.
Yeah.
Yeah.
Yes, we can.
So I'm going to just go through very quickly some of the experiences. Some of them have been amazing experiences, and I've had the opportunity to work with some of the most talented engineers and colleagues from literally all over the world. And I think a lot of the engineers I've worked with, and I am working with in West Africa, are incredibly talented, and but people don't hear about their achievement, and it's always underplayed. So I was born in Bethnal Green in East London. So I'm in East London and I still live in East London. My parents came over to study back in the 50s, and they met in London, and they had most of us in London, and then went to Nigeria and then Freetown, Sierra Leone, where I went to junior school, primary school in Freetown. And then my dad was one of the first Black expatriates that was actually asked by Sierra Leone when they got independence from Nigeria. So he was actually sent from Nigeria to Sierra Leone. And I went to school in Freetown. I also went to school in Connaught, where the diamond area of Sierra Leone is, which is up north, which was quite a fascinating experience. So my first day at school, I remember we all were put in classes and we were taught what you do when you encounter snakes, scorpions, iguanas, and all the predators you got to deal with being in the middle of nowhere. So it was a wonderful time. Really had a great time being in the bush, in the real seriously dense forest. It was great. Then I did my secondary school in Lagos, in the hustle and bustle of Lagos, and we were discussing this earlier before this started. I went to one of the worst schools in Lagos. My school was so bad that you had to finish school and then apply to take your O-levels or WAEC as an external student. And they closed my school down 2 years after I left. So from there, came over to Bristol to do a diploma in building construction. My dad was very keen for me to do architecture, but I met one of his friends in Lagos who was an architect who also had an engineering company. I was about 14, I think, at the time. And in the drawing office, there was this one person sitting on a podium with a double elephant drawing board, huge drawing board. And I walked up to him and I saw he had this drawing on his drawing board with so many lines. It was a reinforcement drawing, so many lines. So I asked him, I said, "Did you draw all this?" He said, "Yes." I said, "Do you know where everything is?" He said, "Yes." And he explained to me, knew the size of every reinforcement, where they are, what they're doing, and everything. And I can remember standing there thinking, this must be the most cleverest guy on the planet to be able to do this. And since then, I was very keen to do structural engineering and civil engineering when I did find out. Anyway, I spent 2 years in Bristol, did a diploma in building construction. And back then, this was in the mid-70s, once you finish your diploma, you then go to a polytechnic to do a higher diploma or something else. There was only about 3 universities in the UK that actually did a course in civil and structural engineering, and they preferred people with A levels. But I was determined to actually go to university, which I got in by the skin of my teeth. So I arrived in Bradford, and at Bradford, only to find out very, very quickly that I was, within the first time, I was the only Black person in the whole engineering department at Bradford University. And that was fascinating. I was on the 4-year BEng course. And from about the first term, it was clear to me that me staying on this course is going to be a battle. So every day was me putting my woolly hat on and actually going to battle. And during the period of me being there, I must have reported 2 or 3 of my lecturers to the board a number of times. So it was a battle getting through the course. And the year out, Bradford University, being one of the universities that did civil and structures in the UK, used to have 100% of their students get placement for the year out, except for my year. So I could not get a placement. So I was asked by the department to swap directly to the final year, to then do a BSc in civil and structural. And I said, no, I signed up for a 4-year course, and a 4-year course I'm going to do. So I'm going to go out and find my own placement, which I did. I managed to get a place in a council in North Wales, where I did my placement, and the university then registered the college, the place as a placement. And from what I understand, every Black person that followed me for the 2 or 3 years after that went to the same place for placement. And I think I was talking to Gabriel earlier, I think Devon went there as well. And while I was there, I opened a Taekwondo club, martial arts club, and ran the club. And over the period I was there, it became the biggest club. Bradford was very good on rugby. Rugby was the big club, but we actually had more members. It became the biggest club in Bradford. And while I was there, I got my black belt in Taekwondo, and then consequently went on to become a 5th Dan in Taekwondo. And I was, for about 5 years, I was lightweight British lightweight champion, both British and English lightweight champion. So I had this career in martial arts, and also ran, and then obviously when I moved to London, I ran one of the biggest clubs in London in Taekwondo while I was doing my degree as well. I stayed in Bradford and did a master's degree. And the master's degree, one of my tutors was absolutely fascinating. He said to me, Albert, you should join the master's course. And I think there was only 3 universities, 2 or 3 universities, Imperial was one of them, who started a structural engineering course, a master's degree. And 5 of us were on the course. I had no money, but my tutor said, join the course. He was head of the course. He said, by the time Bradford University realized you haven't paid your fees, you'll be halfway through it. We'll both get dragged to the committee, from the committee, explain why you haven't paid your fees, and we'll sort of find a story to make sure you finish the course. And that's exactly what happened. We got dragged in 6 months later. Anyway, I finished out of 5 of us that was on the course, only 2 of us finished. There were 1 Iranian, 1 Iraqi, myself, and 2 English guys. All of them left. The Iranian left to join the Iran-Iraq war. So only 2 of us finished the course as the 2 first people to do the master's course in structural engineering from Bradford University. My first job, I wrote 160 applications to get a job, 1 job in Bedford. And while I was at the interview, the guy who won the practice walked in and said, I don't care how qualified he is, I'm only going to pay him the same as the draftsman. But because, and I had no choice. So my first job was that. But moving on forward, I worked for Gregory and Associates in Bedford, and for Price and Myers, and then Anthony Hunt, and then we started AKT. For me, design is all about people. And I was fortunate enough to meet 2 of my partners, a guy called Robin Adams and Hanif Kara. So we got Asian and English and myself, and we started AKT, Adams Kara Taylor. And that's where the AKT came from in alphabetical order. And we created a very diverse organization. When I mean diverse, I really mean diverse. And the strength of that diversity has been amazing. And I think from memory, we have something like 35 nationalities from literally all over the world working for us. And that diversity, you can see the Nigerian flag there, is what, in our view, design is all about people. And it's a community, and it's an exchange of ideas and cultures. And that's what we've done. I'm just going to give you a very quick insight as to the organization, because I think it's very important. As a design-led organization, when we started in 1995, our view was to sort of change the approach of how people perceive multidisciplinary in terms of a multicultural company. At that time, there was not one organization of note in the UK led by either an Asian or a Black person. So we had to be very strategic in our approach. So you had the two faces of our organization is Hanif Kara and myself. Whereas Robin Adams, who's the English member of the team, he was an MD, and if I'm honest, we didn't allow him out. So the client facing was for us. This is an old slide, but it just shows you the structure. We created a structural design organization with a part team from day one, which is a research team where we've got mathematicians, script writers, architects, and they do research in terms of engineering design. And we also have an envelopes team where we looked at facade, not in terms of glass, but in terms of the whole facade makeup, where we're doing everything from composites to bound earth research. And then we also have a very innovative infrastructure team, a small civils team. The total, we're roughly about 370 staff, and we probably are the largest structural engineering group in the whole of London, compared to Banon, compared to all our competitors. London is our doorstep. This gives an idea of some of the areas and some of the projects we've done around the inner London area, and we've done that over the years. And we've just to highlight some of the well-known projects we're doing some of the tallest residential in 190 Elms, over 200 meters tall towers, 2 of them. We've done the Needle High Point with Rogers, and the Crown Place development, and also in Canary Wharf, we're doing the Mirren Circular Tower as well. We're also very internationally focused, and all the green areas are the countries where we've done work. Somehow we've never quite managed the continent of South America. I've been to South America a number of times, but we never quite make it. But we also have, because we're a very design-led organization, academia is very important. So we have academic involvement literally all over the world, and we do a lot of workshops, seminars, and try and, as Dr. Popola was talking about, in terms of learning from other people and exchanging ideas. So I've sort of tried to highlight some of the international projects. I sort of lead the design side, both Hanif and I, but I probably lead the design more the international side of the practice, both UK and international, but these are some of the projects, and I will highlight some of them in my talk as I go along. The way we've set everything up was to basically not try and get ourselves pigeonholed as to be called either your transportation engineer or your bridge engineer or your offices. We have a situation in the office where we all sit in open plan offices in the white collar factory, which is one of our buildings. So the top left-hand building in the old street roundabout is one of our buildings, and we occupy 2 of the 2 floors there. And we have open plan office approach where we all sit with everyone. And we have a rule in our office that if any junior person come and ask you a question, regardless of what you're doing as a senior person, you have to respond to them immediately. You do not send them away. And that way, you get to understand where they're coming from, and you get to get a better understanding of what's going on and be able to interact with the office much better. So we do not, although we work in all these sectors, the pavilion, the big pavilion, we've done all of that, bridges, we're very strong on research. We also do things where we mix every 6 months, all the young engineers, we move them from teams to teams so they can get experience across the office. And we encourage people to talk to They don't have to talk to the line manager. They can talk to anybody in the office in terms of design. And also the innovation side, we're very much into new materials. We engineer an existing building. We've actually designed for English Heritage the oldest cast iron building in the world. That's actually done before the cast iron building in Chicago. So we've done that. Reuse of foundations, actually prefabrication, and we also do a lot of our own internal script writing and modeling in writing our own software. These are the academic institutions we work closely with. So my partner, Nif, runs a unit at Harvard with MIT. I'm the tutor for the research master's department for the AAA in London, which I've been doing for quite a while. And then we're also involved in all the leading organizations. And one of my guys is a professor at UCL. So we make sure we're involved in the right organizations and around, not just in the UK, but internationally. Now, I've put a sort of few slides together to talk about my approach in terms of the design philosophy, how I see design. And so far, if you can help other people to view design in a slightly different way, it will be good. This is a mural we've got in our office, and we've put this together to try and get people to explain the whole issue of design, engineering design. Engineering design is not about engineering. The numbers side of what we do is a given. So if you're an engineering at the table and you're asked to solve a problem, the numbers side and the mathematics is a given. The issue here is to actually create a situation where you have empathy with the whole reason for why the project is being done. And that is best done by actually bringing together a number of issues. An engineer, a design engineer, actually is almost like a conductor. You have to bring in issues of fabrication, analysis, parametrics, geometry, color, space, volume. And the essence of that is questioning everything, questioning yourself, questioning everything. Why is the reason for this? And we have to push the boundaries of engineering, which includes challenging the codes. The codes are a minimum, are written to actually deal with the minimum parameters. But if you want to do something different, you have to move above the minimum. And for us, that is what design is about. Historically, as we know, design starts from mainly compression structures, the pyramids, what the Aztec does. And the more we get to understand materials, mathematics, science, how things can behave, and in our profession, there was a separation between engineering and architecture, design side. But that doesn't mean we should not work and have the empathy for the guys who are the front end, who are the designers and the architects dealing with the clients. And sometimes we miss that. And what we found as AKT, and when we started, and for me personally in my career, was to actually go for the most difficult projects in the office. The more difficult it is, the more challenging and the more parameters it creates. And with those parameters, you can do something different and something interesting. So parameters should not be seen as a reason not to do good design. It should also be a reason not to explore the sides of our industry. And it's clear as time goes on, we don't stand on the elephants anymore. We have to carry the bloody elephants, or two of them, in terms of how we make buildings and structures work. And we also got to deal with climate change, which has to be embedded in terms of our thought process, low energy, low carbon, and also deal with the modern methods of not just infrastructure, transportation, and fabrication. So those are some of the impacts and stuff which are very important. Innovation is the key to what we do. And there was a whole conversation in the sort of late 1990s, 2000, that innovation is stuff. I don't believe that. Innovation went through a process where it had to change from the practicality of innovation to the research of innovation, because as soon as the microchip was invented, there were a whole new raft of engineers came into being, and those engineers had to go through the process of understanding the capacity of what they can do with this new tool. I remember when I was at university, my undergraduate project was one of the first, only the postgraduates were allowed to use the computers. I think there were 3 universities, and I think it was Imperial, Manchester, and Bradford, because Bradford was an Institute of Technology before it became a university, and it did nuclear physics, that had the cyber computers. And myself and 2 other guys were the first to be allowed to use computers at the time. And the computers we were allowed to use were the old cyber computers. And you can only do 2 runs of a run in a day, which means you got to get to the computer center before 8 o'clock in the morning, put in your punch cards, go back lunchtime, look at all the errors, correct it within an hour. The next batch has to go in by 1 o'clock. And then if you're lucky, get it at 6 o'clock. Only the postgraduates were allowed to use desktop computers. And what was around was HP computers, and I remember when the first PET. So my first project was using a 16K memory computer, 16K. My watch has got more power to do my first project. But as soon as the processor came into play, the rate of invention just goes up. And now we're talking about quantum computers, artificial intelligence, and all of that. The issue here as engineers is how do we enhance that and bring it to the practical level of actually doing the physical form, which is what we do as engineers, as design engineers. So, but within that, you need to provide constraints. Without the constraints of the fact of construction, manufacturing, and transportation, you cannot convert those ideas, testing, from a theoretical position of what's in your head and the ideas you've got on paper to the physical. So those chaotic nature of design should not be seen as negative. It's a way of our own computer in our own head and the way we process design. In our office, and this is the wall at the back of my desk, it's all about sketching ideas. Nothing in the whole process of design is idiotic. None of it is wrong. It's just a different way of thinking. And by enhancing those way of thinking, those ideas, you're then able to progress. And you may go forward 10 paces and have to go back 8 and start all over again from position 2. That is what design is about. And in my view, something that should be celebrated. Pushing the boundaries. I'm going to sort of use this area to just, I've chosen about 10 projects. In my career so far, I think I've done over 130 build projects. More than that, I couldn't from memory. And I'm just going to go through very quickly some of those issues. As I said, my first job was back in 1984, 2nd of January, with Gregory and Associates in Bedford. Then I moved to Price & Myers, and the first project that was of note, which was 353 Plaza on Lotts Road, Kings Road Junction. And it's one of the first planar glazing glass roof, tension roof, and a glass wall. And it was done with Pilkingtons back then. And when the architect put the idea forward and the client was excited about it, I remember my boss, who was one of the partners of the company, says, no, we're not doing that. It's too risky. There's no code. We're not going to do it. And we shouldn't do it. Fine. Then he went on his 3 weeks holiday. And as soon as he went on his 3 weeks holiday, within that 3 weeks, I got the client to agree, I got the architect to agree, got it tested at Kingston University lab. And by the time he got back from his summer holidays, it was all done and dusted. And I can remember he called me into his office afterwards, and he really tore the skin out of me for actually encouraging the design. It got built. I had to be on site personally literally every day during the process. Moved on to join Anthony Hans. And Anthony Hans was a challenge, got involved in the floating bridge in West India Dock footbridge, where I took the client to actually go to the Royal Academy and look at footbridges. And the whole idea of doing an opening floating bridge was seen as impossible. But nothing is impossible. By actually we use 4 sets of 10 meters by 3 meter pontoons, and then we pre-stress them into the water 3/4. So you only seen 1/4 of them. And by doing that, we were able to then create this stable floating bridge that the centerpiece opens. And then went on to do other things. But the whole issue here was the design intensity. Design is not a bad word. It's actually a way for us to expand our understanding of what life, space, and living is about. So over the years, that design intensity has gone on, and as AKT, we encourage it to develop with other people. So these are some of the early projects: Lost 353, the floating bridge. You can see the small section where that opens, and that's done by a counterweight. So we've only got a tiny little motor which we slot into the central spine of the bridge. So the bridge was fabricated by Littlehampton Welding. Bill Totten just passed away recently, and we floated it up the Thames from Littlehampton, and then it was literally connected into place. And then one of the other projects, one of my early projects I did that before AKT started, which I was very proud of, was the Sackler Gallery's Royal Academy of Arts in Piccadilly, because he had one of the first glass there in a public space. And back then, you didn't have laminated glass or toughened glass. It's actually just float glass. But by taking a float glass and encapsulating it tight in a stainless steel ring enclosure and going through a testing process, so we actually got it approved, not by any codification process, but by actually a testing process. So we tested it to destruction, and it stayed in place, and it met all the loads and everything, and it was then built. And the one I'm very proud of, the building, the Royal Academy is a Grade 1 listed building, and we were still able to do some work on it. And we created these portal frames for the gap on the 3rd floor. And by creating the portal frame, the architect, Norman Foster, was very clear. He wanted the glass on the roof to actually run down without any steel members and put a very simple pin. And we were able to do that and still able to provide horizontal restraint to the structure, but doing it in a very different way. And he won every award going for Foster. It was the first refurbishment building that Norman Foster did, and he won every award going. Now, I've got roughly about 10 projects which I've put on. I'm going to run through them very quickly and use them as a way of actually explaining some of the challenges and some of the stuff we've had to deal with. So I've got a fantastic team I work with, and design is a teamwork. So I may lead the projects, but having young people and people with ideas around you is the way to go. And that's the way we've approached this. And the first one is the Google headquarters in London, which is at King's Cross. The architects is Thomas Heatherwick and Biaki Ingalls, big, and with BDP, the executive architects. So this is a building which is 300 meters long. So it's actually the same size as the Shard, but horizontally. And just going back, it's roughly at the far end of the building is about 66 meters, and it's about 22 meters at the front. It's about 12, 13 stories on one end and down to 8 stories on the other. And the concept is that you got the boulevard next to the building, is to open up the boulevard, and this building, the whole ground floor has got no columns at ground level. There's no external columns to this building. So the way it's been done, or the way we've done is we've got a series of frames at roughly 9 meters with these 2 columns. We then run into the cores, and then with trusses that staggered up from 8th floor to the 12th floor, and they literally hang the external wall and all the floor structure. Every 3rd floor or 4th floor is a concrete structure, and in between we've got timber floors. So this is an image of what the aspiration. So you've got these timber floors that are not supported. They're actually hung by the floor above, which then hung back to the concrete floor, which then hung by the truss on the roof. So you get these double, triple height spaces on the perimeter of each of the main floors. And then the other floors are staggered in and staggered out. So these mullions, timber mullions, are best part of about 12, 14 meters tall. And you got flats used to hang the building, which are a reflection of King's Cross and its Victorian heritage on steel plate structure. So this gives an idea of the floor plans. These are literally level 3 to level 6, goes right up to level 12. So we've got concrete cores. We've got the best part of 5 concrete cores, and between those cores, you've got these trusses with these sections, and then they hang the external. So the whole of the ground floor is opened up without any support. So this is on site right now, and this gives an idea of the frame. So we use visualization. All of these images, and none of them are the architect's image. They're all ours. We do our own visualization. We use the visual 3D modeling and everything. We work with Rhino, 3D modeling, any of the modeling packages we will work with. And we always tell the actor, just give us your raw model in any format you work with. We will do the conversion internally. And we use them to try and understand some of the overall concept. You've got to start back from a micro to a macro level in terms of how the whole structure is going. So this gives an idea of what we're doing. The most challenging thing with this project was the fact that we're creating the largest amount of commercial CLT timber floors probably in the UK. And every CLT floor, from a sustainability point of view, they have to add 75 minimum of screed or concrete on top of it to deal with the damping. We are not doing that. So we are going against the norm. We've had to bring Exeter University in. We've done a lot of research in terms of movement to get the response factors, to bring 95% of the floor with response factors below 8, which we've been able to manage. And that is done by research and actually doing a lot of testing. So it's on site. This was the biggest challenge we had, and we've managed to do it. The next building I was going to talk about is the Google headquarters in San Francisco. And we were called in. Google had been working with some of our usual competitors for about 7 years, where they're trying to create a series of master plan. And this was being headed up directly by Larry Page himself, Mr. Google, to try and create a headquarters in light of what Apple was doing, creating the ring. So they held a competition, international competition, where they asked a number of architects and designers, not just architects and designers, to come and give them their ideas. In doing so, Thomas Heatherwick and Biaki won the project, and we were called in to try and actually bust some of the myths of engineering. The client was very much inspired by Buckminster Fuller. So the whole idea of the master plan was to do something like 5 to 6 million square foot of spaces. So the first bit was to do a master plan and go into planning, outline planning. And he was really inspired by Buckminster Fuller in the 1950s in terms of how you can create a lightweight dome and create beautiful enclosures with walkable spaces internally. And his inspiration is that all the offices of Google in San Francisco have got best part of hospital quality air, is what he wants his staff to engage with. So what that meant was he was very keen to create a series of these domes. So these are some of the images that went in for planning. So we went through that process, very complex. So by having the best part of 130-meter domes, and the whole principle was to go from a situation of creating a dome with a human scale internal with mingling on a park area, which is like a kit of parts, and then the analysis and the digital and analog approach to make that happen. And then we come to the materiality and the fabrication. By actually creating this canopy, you're then building inside the canopy. And the way Google works is that if they've got a team, they can change a team very quickly from about 10 or 20 people to 50 over a weekend when a new idea comes through, or they want to develop an idea or shrink them. So they want to be able to change the layouts of the floors either over a weekend or a week. So we then talked about robotics and using spider cranes and all of that, and then create the dome kit in terms of. So these are some of the processes. I hope you can see some of the animation. These are some of the processes we had to go through: freeform finding, warp analysis in terms of creating we started with a cable system using a glass enclosure, using glass in terms of the enclosures. And then we developed that further, wind analysis. And remember, we're in San Francisco, one of the highest seismic areas as well. Some of the analysis we had to stimulate was also to make sure there's no ponding. And by creating these visual approach, it allows the client to understand some of the thought process of the design team. And this shows you an idea of some of the views or the vision they had for some of those internal spaces. And these are some of the issues we actually we developed, was to say, if we can end up with sort of robotic cranes, we can clamp onto the columns, which allows you to then remove panels, move things, and use spider cranes to lift and deal with some of the robotics that can be done internally. And then we had to use dynamic relaxation and force density to look at how this is all in real time, so the bottom one is a bit slower, how we can actually create this dome by actually forcing a cable net into place, or allowing it to relax and deal with the deformation. So the option we first started with was a cable stay option, which you can see here, with a huge ring on the perimeter. And what that did was force a huge amount of vertical and horizontal forces at the foundation level, which was impossible to deal with in an area that has got one of the worst ground condition. And in terms of seismic, you end up with a huge amount of liquefaction. And that was very impossible to do. So we had to rethink. So even after we've done all this, we had to go back again and rethink the whole concept. And what we then came up with, what we'll call a grid net, but actually rather than using cable, using a series of flats, 2 flats, and you literally cross each other to create this grillage structure, because the flats create its own inherent stiffness, and that stiffness reduces the forces around the perimeter, in turn reduces the forces that goes into the foundation system. And we then created this dynamic visualization for the client to make him understand what we're talking about. When you're talking about glass panels, so on one hand it's a grid net situation, and the other is a cable net, and the deformation due to seismic effect meant that using glass became a real problem. And you end up, every time you have a trauma, you end up with a huge amount of damage to your cladding system. So by actually doing an exaggerated using the seismic graphs and coding those and putting them into a real-time matrix, it was able to see the effects of the implication of the seismic requirements for California. So in conclusion, we went through all of this over a period of time. We looked at different options, and we ended up, this is the solution. And that solution, this is it being built. This is, I hope you can see this short video that actually shows it in construction. And Arabs are the delivery engineers on this. And And so we did the front end, and they're doing the second part of it. And the site on the southern or to the left, coming up to the left, is the main Google campus, one of many, but the main Google campus in Palo Alto. So you can see this site. And this is it's virtually almost completed now. And then the next project I'm going to talk about is the Halif Center, which we did with Zayed herself from when she was alive, and with Patrick Schumacher. And this is in Baku in Azerbaijan. And at the time, nobody wanted to go to Azerbaijan. It was a no-go area. And this is the scheme, which is a conference center, a museum, opera center. And this image, the top image, is the rendered image that was presented by the architect to say, this is what we're going to do for you. And the bottom image is the real finished building. So you can see we stayed very true to the original. And the whole idea here was that the ground plane was going to be white concrete that then literally goes into these curvatures. So we were called in and we did a competition with the architect and said, of course we can do it. And this is the real building. And how are we going to make, these are images of the real building. How are we going to make this thing work? How are we going to create this? So you had a theater, you had a museum, you had a conference center, a multi-purpose location for the locals. So these are images of the finished product. It's the center. So our work, the first thing we try to explain, and also Baku, Azerbaijan is a seismic region. So the first thing we had to do was to create a very short report with images, visual, to explain to the client all the forces that this building is going to be subjected to: wind drag, temperature effect, lateral wind forces, seismic forces, vertical, large movements. We created that. And then we also created a lot of visuals to say, from a conceptual point of view, this is the approach we're going to take, put a bit of rationality to the form. And in doing so, we split it into basically three elements: the vertical core elements, the lift shafts, the main structure; the horizontal element that form the plates, the floors, the levels, and then this shroud, grillage system, this space frame, steel structure that encloses the whole lot. Each one of these is going to be moving in a slightly different way due to seismic effects. So I hope you can see this, this short movie on the side, which is working in real time from our analysis package. So our part team were able to write from the analysis to the Rhino model. So there's a conversion, and in terms of the movement, and we just put a factor in terms of its movement to show, and this was done in 2009, 2010, to show how the whole structure is going to move, and then in terms of the key areas. This is it being built using a space frame mirror system. The reason why I went from a mirror system, so I went from our truss system to a mirror system, and that is because this is a adapted and adjusted and a mirror system, because they're normally used for horizontal flat roofs to form this shape. And that was because we went to all the fabricators worldwide, and none of them were prepared to go to Baku to build this building because the regime at the time was questionable, but this was a public building. And the key for us, the most exciting part, was doing with the cladding system. So what we did was, our part guys, we actually wrote this software in-house. And this software was to actually pattern the whole of the facade. And you can see, I hope you can see this short movie. This is a movie we did in-house. And we gave this package, we gave the whole thing to the architect. And what he allowed the architect to do was to go through a process of actually determining the size of the panel, of each panel cladding system he wanted. And by doing that, the panel system, by adjusting the size of the panel and the gaps in between, it then tiled the whole building and color coded it in terms of the ones where you're using flat elements and the ones where you've got specials, which are the red, and the ones which are slightly out of. So what he ended up is giving the architect and the whole design team. And then he nested the whole lot and drew everything. And we were able to then give the data directly to the manufacturer to cut each of the elements. So this was done in-house. But to give you an example, which way is progress? The design on the lower section is what we design using trusses, where if you look at the main element, one of the main sections, where we've got 250 nodes and we've got 1,200 elements, the mirror system for the same had 4,700 elements and had something like 410 nodes. But they were the only contractor worldwide who were prepared to go to create the building. So we had to step back again and work with Mirror to make it happen. And this is the building going up. This is the internal. It's being done in all the curvature had to be determined. The geometry had to be agreed. And this is the finished internal layout. This is the concert hall, and this is this is a performance. And this is the building at night. I'm going to run through this one very briefly. This is a very important building. This is a 1 million square foot development that was done in central London. This is the city. This is the confines of the city of London. And this site was one of the last sites which hadn't been developed for a long time in London, in the city of London. And the site was acquired by Bloomberg. And Michael Bloomberg was the mayor of New York at the time. And he said, I've made a lot of my money in the city of London, and I'd like to give something back. And giving something back for him was to try and create the European headquarters for Bloomberg in London. But the challenges was one, it had to be London-centric, and it had to be something acceptable to the city of London. It was very much a well-established historical site. And there was a whole idea of being Bloomberg for it to have a fair amount of innovation. And then underneath the building, along the side, runs the tube line. And after King's Cross, the fire, he said he will actually create a second station a second station. So part of our work was to also deal with infrastructure. So they get a very quick section of the building. And the grid is trapezoidal, about 13 meters, and we use the thinnest steel structure to make it happen. So people come straight into the center of the building. They use lifts to go to the top, and you also have this ramp stair from the second floor to access all the building. So this is the building, 1 million square foot. The challenges was that we wanted it to be, even as an office building, to be openable windows, and it is one of the largest office building in London that hits the BREEAM excellent, highest level of BREEAM for an office building. And a lot of the work was to make sure it was open and filtered through vents in terms of, and keeping the noise away from the building. So, and the facade is polished aluminium, and they had to open an old quarry in Yorkshire just to deal with the amount of stone used to clad the building. But more interesting was that English Heritage were there. We took out 3,500 tons of soil by hand, and had found the largest artifacts of archaeology on the site, so much so that they actually created a small part of a display unit within the building. Now, this was a big challenge for us. The site had 3,000 piles on the site, existing piles on the site. And in London, you cannot build a new building onto old foundations because it will not be insured. It will not be warranted. So the serial guide in terms of how you put a new building on an existing foundation requires you to actually test a large percentage of those foundations, or you extract the piles from the ground. So we were given this and we said, no, we can't do that. The cost to the client and the time program were just completely unacceptable. So we were in the office having this conversation and we just said, we just took the serial guide, tore it to pieces and put it in the bin and said, let's think of a different way of solving this. What we came up with was to actually change the whole scenario of the question. Are pile foundations part of the structure or are pile foundations part of the ground? In terms of insurance purposes, a pile foundation is part of the structure. So we said, okay, we're going to dissociate the existing piles as part of the structure. So we got the, and we said our approach was to demolish all the piles down by about a meter, put some about a meter of hardcore material on there, and put a raft on top of it, and put piles in the areas we have to, because there's a whole series of piles roughly where this on the front of this image, because we had to also excavate 22 meters down to create a new station for the it's not the Hammersmith and City Line, for the City Line. So we introduced literally just about 15% new piles. But the existing pile, we disconnected the piles from the building, and in doing so, the deformation of the raft on the soil then passes the load back to these existing piles. But they're now seen as part of the ground, as ground improvement, rather than seen as part of the structure, and it was able to be warranted. But we had to go through a real battle for that, and we had a real battle with the geotechnical fraternity in London, so much so that the client, Bloomberg, had to bring Ewan Cantor, who was retired as an advisor out of retirement in New York, who's done a lot of tall buildings and very good geotechnical guy, to actually look at the approach we were taking as AKT and the approach the rest of the geotechnical fraternity was doing, and they agreed that our approach and our analysis was right, and it's built. So this is the building, and you can literally see some of the tube lines below. So we created a new station. And this is a comparison between the shard. They're roughly the same area, or just about 1 million square foot each, slightly one, slightly more than the other. But you can see we're using more steel than they are because of the spans we're doing, and the fact that there's a massive concrete core in the center of the shard, which we've got less concrete. The internal, we have this ramp, which we did this model for the client, and the areas where you see the funny bits, it's only supporting a number of areas, a lot of modeling. These are all our own internal modeling system, and this is it built. And this literally wraps itself, overlapping in a helical version across the whole the building, with the views being maintained. And the entrance building was done with a tripartite support system in a 3-dimensional form, which we developed in timber, in sustainable timber, for the entrance and the center of the building. So this is a completed building, and the views to St. Paul's, and the height had to be maintained. And the lighting system is using tiny little LEDs, so you don't get a shadow, get full distribution of light and nothing hanging down. So massive, you know, you can feel the space, even though it's very tight. Now, these are the fun ones. This is the Shanghai Expo, in the 2010 Expo in Shanghai, which we entered the competition with Heatherwicks, and we won it. And the idea we had was to use 10,000 spikes into a building to create a building. So, and these are some of the images we had for the competition. And this was the image we, as the engineers, created. And we said we can get 100,000 spikes through the structure. And we said, well, there won't be any structure left. We said, well, that's our problem, leave that with us. 100,000 spikes using acrylic as a structural material with aluminum to create this building. And it became a diplomatic. So we, as usual, we went through a visual by actually creating, using technology and using the processing power to create these scripts, which we used to explain. So the whole building, we used 7.5 meter long spikes with aluminum. and the foam on the outside is reflected in the negative foam on the inside and the angles. So it's it's literally 20 by 20 acrylic spikes, 7 meters long, in an aluminium, 30 by 30 aluminium casing for part of it. And then the World Seed Bank donated seeds, which were then fused into the acrylic for the internal. A lot of testing was done in London and Germany in terms of the spikes. We used CNC cutting, which was done to drill the holes at 100-meter centers through the whole structure. And we did not manage 100,000 spikes. We ended up with 60,000, just over 60,000 spikes. This is it going up as a timber structure. And then these are the acrylic spikes going in. And as you can see with the slide in the bottom left-hand corner, the ends were then fused with seeds from the World Seed Bank to actually explain the fact that nature and vegetation is very important and they come from seeds. So the brief from the client after we won the competition was simple. With the expos, they always judge each pavilion to see who's the overall winner of pavilion. And the Minister of Foreign Affairs at the time, we had a meeting with them at Westminster, and he said, look here, you only have one brief from me, and the brief is your pavilion has to be in the top 5 of the winning pavilion. So this is the final. So during the day, light goes through the acrylic into this space, and in the night, when it's lit internally, it actually reflects itself externally. So this is the internal, this is the real thing, what it looks like internally, with each seed from the seed bank, 60,000 seeds from the seed bank sort of fused into the acrylic. And this is a video of the finished product. This is not a render, this is the finished building. And it actually won the best building in the Expo and won the Lubetkin Prize, the World Lubetkin Prize for the best design worldwide. As engineers, as raw engineers, this is one of our favorites. And I'll run through this very quickly because we're running out of time. This tower on the left is an existing brutalist tower that was done in 1974. Internal is a waffle slab and the external columns are precast concrete. It became dated and it was empty for a while for use, and it was then put up for sale. And the client, all the clients were to demolish it and do new buildings. Our client called us and says, guys, what do you think? Can we put the original engineers who are still around say you can put 4 stories on it? Can we put more? And I said, I'm sure we can put 8 stories or more on it. He said, sure. I said, yeah. A lot of strength. I said, no. So we designed it for 8. We bought the building because it doesn't have to demolish it. So from a sustainability point of view, it's probably one of our best buildings. And because we argued we couldn't, and then he said it didn't work for him, he needed more than 8. So we said, let's do some more detailed analysis, give us 3 weeks, which we did. And we said we can actually add 13 stories to a 30-story tower. And everybody thought we were taking the piss. And it went in for planning, so much so in Southwark, the other borough actually objected, and boroughs do not object because they thought it was an April Fool prank of trying to put we actually end up putting 12 stories on an existing 30-story building, about 30%. And this is it. So we put 11 stories for the planned floor, and the podium building, which was 6 stories, we added 3 more floors. So 50% on the podium building and 30% on the existing. And we did not strengthen any of the columns or any of the foundations. We didn't even touch the foundations. And this is what we did. And there's a tube line running literally right underneath it as well. So movement was important. We had access to all the existing drawings. And one of the key issues was to take the core, which was a commercial core, and reconfigure it into a residential core. And in doing so, we were able to improve the stiffness by about 7%. And reconfiguring it allowed us to do some of what we need to do. But we also, and this diagram, engineers would love this. This diagram, the top one with the red ring, shows the existing tower and how the core has been considered, how it works. That is how it was designed in the 70s. The middle one is actually how it works, because each slab is acting as an outrigger system to the external. What we've done is actually pre-stress the core by adding more load to it. That way, it never goes into tension any longer. And it uses each floor again as an outrigger, and we're able to get it to work. We've got our own CFD analysis in-house, which we wrote and developed to do with actual wind loading, and it's certified. We were able to then understand exactly how the wind forces act onto the building. And we were then able to then increase the core. This is going up, and this is the top, the flat tile. So the client was very pleased. Financially, it was a big win for him. And this is the finished building. The last couple is the Sheikh Zayed National Museum. I'll run through this very quickly. This is now on site. Competition we did. Sheikh Zayed created Abu Dhabi by bringing all these regions together in the mid-40s, or 1959, 1957, mid-50s. So they were going to try and do a number of museums in Shadiat Islands. We entered the competition with Foster & Partners, and the design we did was this, very low key, very sustainable, because we did Masdar. So we knew how to work in the region. And we won the competition. They said they hated the design, but they loved the approach we took in terms of our thinking. And so Foster's and ourselves won the competition. And they were looking at 3 museums. The National Gallery is the one in the middle. Zaha was in the Maritime Museum. The Louvre is finished. Jean Nouvel and Google North was doing the Contemporary Museum. So, having won the competition, they said the idea, the client, was to Falcon is something they love and they want something to reflect that. So the whole idea was to have 5 wings, which are up, the tallest wing is about 115 meters, 120 meters tall. And inside each one of these is a gallery and create a mound. So the first thing we did, we thought this is going to be a nightmare as you change things. So we asked the architects, what are you going to use to do this? And they said they're going to use 3D microstation. We said, fine. So they created the original form in 3D microstation, which was fine. And then we then did it and then create some parameters by actually using tiny little stainless steel tubes for curvatures and box sections for verticals, and created these nested elements. What we then did was wrote parameters into the software and then gave it back to them and said you can now play with it and create whatever shape within these parameters for these wings as you wanted. So by the time they gave us back the forms and the shape, we knew it would work. We didn't have to worry about it. So the way we split it up was the curved elements were tubes, the vertical elements were box sections, the connection nodes were going to be a series of the same typology, and then that created the form. So this gives you very simple elements to allow them to do what they needed to do. And in doing so, this is a rendered version of what was then produced from that. And then inside each of these wings, are going to be 5 galleries, and each of those galleries will be hung to create a complete open space below. And this is what was done. The project stopped for about 7 years. They actually dug, and then all the recession hit in 7 years. And then it started again. The engineers who are actually doing the delivery engineers at the WSP on our behalf, and they're doing a great job. And they saw it's changed slightly since then. And this is a short, I hope you can see this very short video. It's now back on site. This is from a few months ago. It's being built, and it's the second one after the Louvre in Abu Dhabi that's going to be completed. But it was designed quite a while ago, so it's now on site. So we're quite proud of it. And I must admit, I'm also quite pleased and quite proud. And this is now how it's going to look. But they've kept the whole concept of keeping all the, the underside free and the galleries basically hung. So we developed the concept and we actually took it to detailed design, but obviously with the times changed, but the core concept and the ideas has been maintained. So hats off for WSP, they've done a great job. This is one we're very, very proud of. This is the vessel in West Side of New York. And related, we're developing the whole of the area on a podium. Underneath this building is the rail tracks and the bus track. So all of this is on a podium. And they wanted a sculpture internally, and Thomas was asked to do it. He called us in and said, let's try and do something interesting, something that can be useful, not just a sculpture for people to sit and take photographs. And this is Hudson River, and the next it is Hudson Yard, and this is it. And this was his idea. The idea was take people from the ground plane looking at all these tall buildings and give them some elevation so they can actually see the beautiful views as well, geopublic, and they can enjoy the sculpture at the center of the whole of this development. This was a real challenge for us because the shape for the staircase, we came up with a wishbone where you had staircase to be able to access each level. And at each platform level, you can sit there, you can have your lunch, you can put a table there, and then you can actually use it for concerts. And we then had to rationalize it in a mannerism that allows it to be built. The beauty about this is this structure, there's no difference between the architecture and the design and the structural element. They are one element, which means design, the best designs are the design where the architecture and the design and the engineering work hand in hand. The issues we had to deal with was the dynamics of people walking, people running up and down staircases, and if there's a concert, everybody having a dance to the banjo or having a concert. So the dynamics of each one. So we've got some dampers in it. So as I said, the form of the whole structure is also, of the architecture is also the structure. So the geometry was very, very important, which we established the geometry, everything in 3 dimensions, and everything was done like that. So this gives an idea of the maximum amount of people you can have is 2,800. And then we use these images to explain to the client what we're trying to deal with. So, and by actually looking at stadia, the R value of stadias, for grandstands, for normal buildings, all the sources of floor vibration that can happen from people and from the trains, escalators, and external vibration, what it means to this structure. So we went through all this, and we also created these dynamics. These are the 3 first modes of movement. The first one is vertical, and the other ones are swinging, which we accelerated and we were able to explain to the client and show to them. And this is a very short video that shows in the opening of the structure, and you can see the views from the top of it. Now it's being used for people doing their exercise in lockdown. They're all running up and down the stairs, doing their steps, and and it's so we're quite proud of it. And this is the finished product. And that's polished bronze. This is a single image of a project we did in Ghana, which is the tallest residential building, 25 floors. And the client is now a very good friend of mine. We were calling to look at it. And I can remember one interesting conversation we had was to say, and I said it had to be all done with local materials as much as possible. And the biggest conversation we had was the foundation. So, well, if you're going to do a 25-story tower, we need piling. We need to pile it. And the rigs that were available at the time would not go very deep and were not big enough. And the cost was as strong. I said, okay, if we need bigger piles, if you're going to go taller, and piling rigs, and Accra is very low rise anyway. As soon as you start getting to super tall buildings, then you need big piling machines. Say, okay, we're not going to buy one. We're not going to do it for a building. So we're not going to pile it. We're going to go to old school 1950s approach of doing tall buildings, and we're going to do a caisson. So we then create a 2.5 level of basement and create a casemate for the plant, and we'll put these towers on it and with the cantilever pieces. And the main conversation was that don't do the externals for 6 months. You're going to end up with settlement in the region of about 50 millimeters. In reality, we got less than 20, and the building was built and the externals was done later on, so there was no impact on the building, and it's still there. And then one of the other buildings we're doing now is this one we're very proud of in the Red Sea, where we're working with Kengo Kuma competition. One Kengo Kuma from Japan and Foster and Partners, where we're dealing with ecology and in terms of what's happening to our planet. In the Red Sea, so we still got some of the live corals, and we're doing this development where we're using sustainable development on an aggressive saltwater area. So we're building all of this in timber. And timber and salt water don't mix, but we are, because we're using pickled timber, Akoya. And the issue here was first convincing the client that that's the right approach, so that we do not contaminate the corals. So in doing this, we're not pouring any concrete. We're not using as little solvents and liquids, anything that can seep into the sea and start killing the corals and not separate. So the whole approach here is understanding ecology and designing and working with experts and people to come up with solutions that can be easily prefabricated and to create these spaces. So these are the spaces, and we're actually we're designing 3 islands. So these are some of the shore things. And this is the final project I'm going to talk about. This is the National Cathedral in Ghana, which we're doing with David IJ. And the literally demolition is almost completed on site. And as a national gallery, it's a gallery to be able to accommodate 5,000 people internally. It's a multidisciplinary cathedral, and a total of 15,000 with the ends open. This is the site, and those of you who know Accra, next to the Parliament State House and International Conference Center, Osu Cemetery, is the whole of the red bit, where we are next to Castle Road, very close to the stadium and Independence Square. So this is it in context along Capitol Way, and the whole cathedral sits in there, and you've got parks on either side, podium building. The building, and this is fascinating, I'm very proud of this building and this design, but we've had to go through a huge amount of battle with some of the client bodies to understand. I really take my hat off for the work that David IJ are doing, and their office in Accra is the one doing it. Because I don't believe as engineers and designers from Africa, we don't need to be apologetic about what we do. We do some amazing and good design ourselves. And some of the convincing we've had to do was to convince people that the whole idea why David won this competition was to actually use references from historical Ghana in terms of how to use the broilies for the elders and the rulers to create a form which is cathedral in its form, and it's of a scale to match any cathedral worldwide. So this project was presented at the World Architectural Festival, where everybody was going, wow, this is, And for me, this is some of the projects where Africa is coming out. Personally, and this is a personal thing, and I hope I don't upset anyone, I am tired of things being built in Africa that is a reference that's been taken for something that's been done in Europe or Germany or China. No, we have some very powerful, some of our sculptors, artists, we've got some very powerful intellectuals and people in Africa. We do not need any more references from from overseas. And when this was presented, there was a whole conversation of saying, oh, why don't you make it a cable stay roof? Why don't you make, no. This, for me, is an approach that actually says this is Africa. It's not, there's no colonial reference to it. And to me, that's the direction we should be going in terms of our thought process. So the challenge for us is, how do you make something that's catenary that it looks like it's going to fold in support? And I still have people saying to me, how do you make this thing work? Does it really work? Of course it does. The geometrical form was to actually, first, was to take the model and then make it geometrically readable from a manufacturing point of view. We are going to build this building using local materials right across. So the roof structure was to do a combination of catenary trusses in a Venn form for the lights to come in, which is pushing the support inwards, right up to a shallow arch, which is also a Verandale arch beam section, which is trying to push the columns out. But actually having the wing walls, which are part of the art, and also the shading, some of them lighter as it tries to push out to reduce the amount of pushing out, and some of them very heavy to counter the pushing. And by shaping the columns, we're able to create a structural system that creates this effect. This is what internal is. This is an early image. They're much better images now by the architect explaining the internal to create this building. So it's 85 meters clear span structure. And this is it in context as a night shot. This is the last slide. I love this slide because it's a different ways of interpreting it. For me, it actually explains what physical design. There's a lot of people that talk about design, they write, draws images, write books in our industry. No, for me, design is participation. You have to participate, you got to talk to people, you have to make it work physically. And it's all about a journey, and the journey is the project. The project is getting this car across. That is the project. And you got people with different attire, but everybody looking in one direction, forward, and working together. Design is about that. It's about it's about people, it's about ideas, and it's about being focused to make sure the project is accomplished. That's it. Thank you very much. And that's the last slide.
Wow, wow, wow. Albert, I didn't want you to stop. Wow. You could go on for the next 3 hours and you will keep us amused. This is fantastic. This is amazing. I mean, you're not just going from simple, straightforward structural engineering. You're taking us back to the thinking behind it. Why is the building necessary? And what are the things you need to consider before you then start ordering cement and brick, and even consider your manpower resources? They have about 10 or 15 questions already pour in as you were talking. So I'm gonna go through some of them, and then I'm gonna ask some people to unmute themselves and ask the questions themselves. Right. The first one is from a guy or an engineer called Tabji. What were some of the challenges you faced during the early years of your business? And then there's a related, don't take that one yet, there's a related question to that. And I think it could be from a young engineer here that says, okay, how did the AK2 manage to grow and run successfully in this business for so long to date? How do you keep ahead of the water? This is actually 3 questions here. What are the lessons learned? And how do you point young engineers into doing this business, especially in Nigeria? What has been your most challenging project as a structural engineer? So let's take that one for now. And that was John, question was asked by Jane WT. Yeah.
Let's take the first question. As a practice, how did we manage it? When we started, nobody knew who we were. And I can remember Hanif, my partner, and I saying, well, we've got to find a way to get people to know first who we were. And we also got to start, we both said we've got to start, we ran all the clients we knew from our old practice. And we were quite surprised that a number of them, a handful of them who knew that we were the ones that actually make things happen, were quite quick to support us. So we never did any extensions or house, we didn't do any of this. And I remember the first project when I decided I was leaving, and I told Hanif I was going. He said, yeah, if you're going, I'm coming, and we got Robin involved. The first client I rang, the very first client I rang was BAE Linton's, Heathrow. And I said, I'm tired, I've just finished a building with them, which is the only building at Heathrow that hasn't got a radar registration. And I said, look, I've had enough of this, I'm off. And he said to me, really? I said, he said, what are you going to do? I said, well, I can join this practice, join that practice. But we're thinking about doing our own. He said, great, I've got a job for you. I said, what? He said, we've been doing sheds at Heathrow. We've got storage sheds, 150 square foot sheds. And we seem to be losing, building them. We want to do a 3-month research on sheds. You're going to be working with this architect with DL, QS and everything. If you want it, I'm going to pay you £30,000. And if the results are good, we've got 350,000 sheds to build. And if you want it, it's yours. And even before we finished our resignation and work our term, we were doing work for BA Linton's. After the Royal Academy, we just got a lift, the one I did with the glass one. The next job we got was the National Gallery in Dublin to actually put a lift in there. So what we did was we targeted all the young, challenging architects who were trying to do something different. Zaha was literally had done hardly anything, and her design was considered unbuildable. So our first big project was the Science Center in Wolfsburg, which we were the engineers for, because everybody said it cannot be done. But engineering is not about what can be done, it's about what can't be done and how you make something that looks impossible possible. You may have to tweak it, change it. So that was part of our approach. But one of the funny things Hanif and I did was that we attended every function party in London, whether we were invited or not. We gate crashed all the parties. And when we got in there, we spoke to everybody we can. So he was Indian, I was black, and everybody knew who we were very quickly. And I can remember we've done all the work at King's Cross, commercial. It took me 4 years of chasing the client on that one. Eventually, it gave us a small concept to do. And very quickly, we ended up doing all of it. So working very hard, creating an environment. To answer the second question, we try and create an environment in our office, almost of a Bauhaus, where the senior people are there to support the junior people, not the other way around. And our clients say to us, we're very pleased with AKT. We know you can do engineering. That's not the point. It's what else do you bring to the table? And one client said to me one time, he said, the reason why we like coming to you guys is that things go wrong in any development, any scheme. And when it goes wrong, you guys tend to put a director on it, and they stay on it until it's resolved. All the other practice, the director will show up, do the talk, and they'll then throw it, because it's a problem, to some of the most inexperienced people. Say, you solve this. We do it the other way around. So we're there to support the staff. And in that way, we encourage the young engineers to get involved in research, academia, to be questioning even what we tell them, to have a conversation. So if we're having our design workshops, everybody's got to say, and if they don't, I say to them, come on, what do you think? Why do you think we should do this? Ideas. So for us, that allows us to encourage our young engineers, and we also encourage them to do other things out of engineering so they understand the whole purpose of design. So I hope that answers the questions. The last question is about Africa. I don't think we've got some amazing engineers in Africa, if I'm honest. We're working in North Africa, we're doing the theater in Rabat. I've done some work. We used to run the office in Libya before everything went bad. We've done some work in Egypt, and I've worked with some engineers from Cuba. We've got some really talented engineers. The issue here, in my view, is confidence and exposure. And we've just got to be prepared to question and challenge what we do ourselves. So I hope that answers, but those are my personal view on this.
Yeah, thank you. Thank you very much. I've got lots of questions here, but I've unpicked quite a few, and the rest that we can't cover because I'm conscious of time. You know, we've been here for almost 2 hours now. The one that we can't cover, we will email it to you. Hopefully you'll be able to respond to us, and then we'll pass it on to them. I've got 1 or 2 guys that have a very pertinent question to ask. Franklin, can you unmute yourself and ask your question? Franklin?
Yeah, hello?
Yeah, hello? Yeah, hello.
Sorry, I've got some feedback.
Hello, Franklin.
We can hear you. Go ahead.
Hello. Hi, Mr. Albert. It was around machine learning, and so the advancement in computing. And you mentioned at one point in your presentation that, you know, ever since the processor came into essentially the world of work and world of engineering, being able to do a lot more complicated designs essentially took an exponential step. Now, with the whole big data and machine learning and algorithms, you know, development in the wider world, how impactful how impactful would that be for the work that you do in terms of structural design and being able to do a lot more complicated designs than what you've done so far?
Well,
okay. Did you get that, Frank? About, sorry.
Yes, I think I got the gist of his question. Right. Machine learning and the development of the processing power of what we do is part and parcel of the development of engineering. And I don't think it's something we should be worried about, because all we need to do is go back in history. There's some amazing work that's been done just using the slide rule. And I actually remember when the fax machine first came into play, everybody was saying it's going to have a real, a disaster for what we do. And I remember when I was at school, when I was at college, you were only allowed to use a certain type of calculator because anything else is seen as... The challenges we have in the future are immense. There are new challenges. I was reading something this morning, where it said that the engineers are looking at, in the UK, where they're looking at using satellites to beam rays down to the earth, to use the rays from the sun, beam it down to the earth, and then capture it and put it back into energy. To me, that's a great idea. It's sustainable. It's going to need engineering. It's a completely different kind of engineering. And I can remember the early days of AKT. We did a whole exhibition, did some work with NASA, when they had the space shuttle, to see whether we can develop a concept of how you can have a folding structure which you can put inside the cargo bay of NASA, so that when it gets onto the moon, it will unfold itself. Now, that can only be done with the power of processing. Now, so I think machine learning is very important, because as engineers moving forward, our ability to do menial work will be less. That would be done by robots. Our ability is to deal with the design and the concept and the engineering to allow them that to happen. It's exactly the same way where we're now using mechanical tools to dig, to break, whereas in the past, everybody there with hammer and chisel. We don't want to be there with hammer and chisel anymore. We want to be there using new equipment, new ideas, creating new materials and moving forward. So I think as engineers, we need to embrace machine learning. We need to embrace artificial intelligence. We need to embrace all of this possible processing power that's been worked on and use it to allow our design to move forward.
Thank you very much for that. Dr. Moses, please unmute yourself and ask your question.
Hello, can you hear me?
Yes.
Okay, thank you very much. I found the presentation quite exhilarating. But I have a question because at the beginning of the presentation, you made a very valid point that engineers should not be stuck on codes.
Yes.
And I noticed that most of your presentations are what I would consider specialist 3D frame structures. And I imagine you would have used either FE or boundary element methods in some of the design.
Yes.
I just want to find out how amenable are these standard codes that seem to focus on maybe just basic hand calculations like the Euro code to the design of this kind of.
You're absolutely right. Now, I think codes are very important. So, and I'm only showing you a certain percentage of some of our work. Some of our other work are fairly straightforward office buildings where, and even with every single project I've shown you, a fair amount of it was done by the codes. The issue is that the codes are written in two ways. You've got the standard codes that gives you all the formulas to work on. And then you've got part 2 and part 3 of the same code where the principle they've used to determine the formulas you use in the codes are established. And it is clear that it gives you the opportunity to use those to actually determine if you're trying to do something that is outside the squareness of the front end of the codes. So for instance, if we talk about dynamics, you can look at the chart in terms of what the requirements are according to the code requirements of doing dynamics. And then in America, they tend to also work with empirical tested versions, which they also use in Japan. You can codify those. You can actually take that and actually go back to the basic criteria that's been used to develop that to do your analysis, and in turn, bring it back to the code to make sure it meets the limits. What's important, you meet the limits of what the code wants you to do. And if you don't meet the limits, you don't have to justify it. So some of the work, like the Shanghai Expo, when we did that, we submitted it to the Chinese government. They said, we're not going to approve this because we only have 5 materials we consider structural in China, and acrylic is not one of them. And it became a issue for the British government. The British government said, no, we can do whatever we want. This piece of land is ours to do whatever we want for our expo, and we give it back to you. So much so that I had to jump on a plane. I had a call, both Thomas and I had to jump on a plane to have a meeting with the representative and the ambassador in Shanghai, the British ambassador and the Chinese. The conclusion was then say, okay, compromise was okay, we're going to take your design and your analysis and your calculations. We're going to give it to a professor at Chongji University. He's going to evaluate it. He's going to say whether it requires standards in terms of safety, typhoon, and everything, which is what they did. And he then went through it and he said, yes, it's fine. It meets the requirement of what the criteria for the codes are in China. And they approved it and we did it. So I don't think the codes, we have to work with the codes. But as I said, design is all about questioning things. Just because the code is there doesn't mean you can't question it. And British standards and code of practice. If you actually look at the word code of practice, it's a code. If you can determine that something works better than what's in the code, without working with the code, will be approved.
Thank you very much. You're very right there. And that's take me back to many years ago when I designed a glass bridge with Thomas Edderwick. It was meant to be located behind King's Cross Station on the canal.
Yeah, I saw it.
And there was no codes to be able to help us. And the whole principle is to be able to bring books together. You go on the shelf and you collect your books, and the pressure you put, or the pre-stress, and that's how we're going to hold all the glass together. We have to go back to testing, analysis, all kinds of things to be able to prove. No code will direct us how to design this thing. We know how to design glass, but to design glass to work in that vertical position and keep the loads on, it was a challenge. So I thoroughly enjoyed that. And some of the projects you've described today is definitely not thinking outside, actually thinking without the box. People say think outside the box. No, make sure there's no constraint and just keep yourself free and, think deep and keep yourself free and be very, very creative. One personal or close to home question here from one engineer Bola Ajayi. Do you have any of your children in civil engineering, in particularly design? Because we don't want this brain to go, when it does go, we don't want it to go and not leave anything behind. Is any of your children following your footsteps?
Well, I've got 4 kids.
Okay.
And I'll just give you, my first one actually lives in Ghana, and he does electronics, and he works for, is the IT manager for DHL International in Accra. My second kid is my daughter, and she's an architect. She did architecture.
Okay.
And she runs her own studio in Stratford in London.
Okay.
My third is my son, another son. He actually did electronics and electrical and electronics, and works for a company, computing, not so much computing, they do hardware and software, innovative company in Cambridge. And my final one, my daughter, she's actually doing structural and civil engineering at Sheffield University. Now, she didn't want to do engineering. She did not want to do engineering. The last thing she wanted to do was what Dad was doing. But she said she loved mathematics, and she did some research as to say, go do some the research. What kind of engineering use mathematics the most? Practical mathematics. When she did the research, she came back and it was civil and structural engineering and aeronautics. So she decided she was going to do aeronautics. But having realized that aeronautics is so limited, she decided to do civil and structural engineering, and she's enjoying it. She's in her 3rd year. So yes, it's still staying within the family, the whole idea of engineering and design.
Okay, thank you very much. That's wonderful. I mean, when you go to the third one, I thought, oh no, there won't be any structurals there, but you landed it with the last one, which is always the best. The best thing comes to those who wait. Wonderful. I'm going to take a final question here because I'm really curious of time here. Engineer Gabriel Ige, can you unmute yourself and ask your question?
Yeah, Dr. Sonne, thanks. Albert, this pretty straightforward question, but 3D modeling, from my experience, the architect will do his own model, structural engineer and MEP, and then you're supposed to coordinate. Do you find that most architects and MEP engineers that you work with, do they actually use that? Do they develop the modeling and do the coordination properly with the structural engineers?
Well, yes and no, because the architect does their very early modeling using Rhino most of the time. So that platform, and a lot of engineers don't use Rhino. We use Rhino. We actually teach most of our staff engineers are to know how to use Rhino. And at the same time, everybody's into Revit. We use MicroStation 3D, we use Revit, not a problem. The coordination side of it, the problem is people are doing it in different stages of the project. The M&E engineer wants to do it last to do with his coordination. The architect does it first, and we're sort of in the middle. And my view is the engineering side of what we do, whether it's M&E or structures or whatever, is much more precise. The architectural side is much more visual. So more and more recently, engineers are doing, architects are doing what we call fairly precise model, but the modeling tend to be a bit more, more to do with the visual rather than the elemental. So for coordination purposes, we're still not quite there yet. So what we tend to do is take the architect's models and we sort of remodel their model and make it more accurate. We always call their models dirty models, and we make all the lines join. We actually have a software that actually look at the element in Rhino, and then it will connect all the joints and everything, which allows us to then create a model, and it automatically creates a model for us, which goes into Sophistic for analysis, or robot or SAP or whatever. And it then goes backwards the other way, back to the Rhino model, which we can give back to them. So that coordination process is slowly happening. And I think talking about processing power and engineering wise is something that is getting better. I remember the first ZAR project we did, which is the Fino Center, Science Center in Wolfsburg in Germany. When we first got there was no straight lines, there was no columns, everything was curved, angular. And we developed our own model to analyze it. And each analysis took 15 hours to do. And that is after we went out and we bought the most powerful machine you can get off the shelf, PC at the time. And it took a long time to every time we want to analyze it. So the whole process of going through that from a modeling point of view was difficult, but we did it. The same model now will probably run in probably 4 minutes, 5 minutes, and it allows us to coordinate. So we take their model, whatever way they give it to us, we tidy it up, allows us to then, for it to create our model, to do the analysis, do the changes and give the model back to them. We do that a lot with most architects. And it doesn't matter whether we're working with Foster's, Thomas, or David, or Rogers, or whatever, whichever architects we work with, as long as they've got the capability to do it, we say, hey, you give us your model, we'll give it back to you. But it helps with coordination, makes our life easier.
Fantastic. So you're managing the architect basically.
Well, we manage part of the process that affects us. Yes.
Yeah. Good. Well done. Thank you.
Right. Thank you very much, Albert. This is amazing. I'm just going to have a very quick summary of what you've shared with us today, and then we're going to close it by advertising some of the other events that we have coming up very soon. You've taken us from your journey from London to Sierra Leone, then to Nigeria, and then back to London. And you've shown us that we cannot mess up with you because of your skills in taekwondo, martial art, and you know what. So if anybody trying to misbehave, I'm sure those skills are still there, and you can put them to use anytime at all. So thank you for that. You've taken up from things like the commercial offices in Italy, in London, to a building which are mixed use in terms of accommodation combined with commercial. And then you look at housing, the athletics village in London, the Village Geo Vista in Accra, which you show. I love that building. Every time I come after the airport in Accra, that's the first thing you see. Then to the cultural building that you've worked on, structure in Azerbaijan, and also Abu Dhabi, the Zayed National Museum, the Leisure and Sports Center, the UK Pavilion. I remember going in for this competition with Myad Architects. which is a colleague of mine, Ali Manjera, who went to university together. You know Ali very well. Yeah, so we compete with you guys. We have done it before, although you're more successful than we are, but we don't give up. We keep going. And then how you embed research and development. I mean, you said that engineering design is not engineering. It is about creativity. I love that. I really love that. I wish I could embed that into my student brain when they come in with their calculator. Say, no, leave your calculator behind. It's about your creativity, what you see around you and how you use it. And talk about students, I would love to see how we could get some of them to come and have a work experience with you, especially those one in the early ages, not even undergraduate. Undergraduates have to apply in a normal way. But those students doing A levels or just finished their GCSE to come and have a taste for one day what it is to be working in an engineering firm. And that would then, build their mind and get them to start thinking differently. Your floating bridge is just floating glass. It just amazed me really, because you never think if anything say float, it needs to move. It's floating, but it's not moving. It's just keeping people from one end to the other, and goes on like that. Your vessel, New York, the Red Sea, idea of sustainability and using different material, and then you conclude it with this cathedral in Ghana. When I saw that face, all my friends, me, I like to share things on WhatsApp. They would say, "Oh, here we go again. Africa, all they do is church and mosques, religion. They don't spend money on road and they don't build hospital." I said, this one is different. I didn't even know it was you guys are involved. I had to explain to them. People go to Rome to go and see the cathedral in Rome on holiday. People go to Saudi Arabia to go and see things. Africa does not have, apart from those pyramids in Egypt. Yeah, we don't have anything big that people could come. And the amount of money generated from tourism. So I believe this cathedral you've designed here, I'm going to see when I get to Accra next time it's being built. I hope this one will signal Africa in the world. People will come from all parts of Africa, all parts of the world to come and see these structures. So on that, I would like to say thank you very, very much. This has been a fantastic. I mean, there's more questions coming in, but we just have to post that to you so that if you are able to answer them, then we'll give them
I will.
Okay, thank you very much. We really appreciate you guys. If you want to show your appreciation for Albert, we haven't finished yet. I'm not going to unmute you, but just clap and just clap remotely, yeah, for Albert. Please.
Thank you very much. Thank you for the
amazing work. Right, thank you. Right, so we're now moving on to what we need to be aware of in the few weeks. As you know, we're a subsection of Nigerian Society of Engineers, and every year they have their National Engineering Conference. And this time is coming up from the 16th to the 20th of November. It's about a week from now. Oh no, it starts on Monday. And there they'll be looking at engineering education and lifelong learning opportunity for sustainable development. I'll be making a presentation on Tuesday from 12:30 to 1:30. And my presentation is going to be about engineering education in the 21st century. Yeah, as you guys know, education or a classroom is one thing that haven't changed for donkeys here. Our phone have changed, even our glasses have changed. Classroom is being taught, or students are being taught things the same way it was taught 200 years ago. So I'm going to be sharing with engineers in Nigeria what we need to change, how we need to change, how we need to bring the new 21st century education into the classroom. And then, so that's from the 16 and 20, you need to register. You need to make sure your payment is up to date. If you don't have it, there's a website there that you could go into, conference.nsc.org.ng. You could check what you owe. It shouldn't be more than about 9,000 naira, nearly 9,000 pounds, 9,000 naira a year. And then you have to pay for the conference, which is about 35,000 naira. So please do join and let's support them. And then we have the Manchester branch of NSE. For those of you who don't know, there are two more branches being created in the UK, the Manchester one and the Glasgow. The Manchester one have a conference on the 27th of November at 5 p.m. London time, I think. And the topic is on the techno-economic feasibility analysis and environmental impact assessment of isolated solar rooftop PV system. That's quite a long topic there. That's a paragraph on its own, by engineer Nabila Ahmed Rufai, PhD, SMIEEE. I think that's just a member of an organization there, but she's a PhD holder, and she's going to be sharing with us on this particular topic. Because for me, PV solar is a done deal. Yeah, you invest in it and you get your power for free, as far as I'm concerned. Because the whole Africa is daylight sun that we get is sufficient to run the whole country or the whole continent. So that's that one. And then we're back here in NSE London, where we're going to have Dr. Larry Jones on the 28th of November, the same time, 2 p.m. He's going to be talking about infusing knowledge management in higher education in sub-Saharan Africa. And he's going to be using Nigeria as a case study. He is an educator. He works for University of Sunderland, and he does a lot of things for students and young people. So he's going to be sharing his view on infusing knowledge management. That's one thing that engineers really need to know about, not just young people. And then, as I've said before, as some of my colleagues have said, you need to help us. You need to come and join us. I don't know if Theo have anything else to say on this. Theo?
Yeah, just want to just say thank you for coming today. And also, we need more people on board, as you have just said. Not only that, as soon as you get information of our programs and webinars, can we please cascade it to our colleagues and friends via our WhatsApp fora? Let them be aware that, yes, there's something big that the engineers from Nigeria, they are putting together here. And I believe definitely we will definitely be going from leaps and bounds at the pace we are going. Thank you very much for coming on this webinar for today. Please, let's put those dates in our diaries. We have our email addresses there on the screen for anyone who would like to contact us. Any question whatsoever, any inquiries, engineering-wise, that we can assist or support, let us know about that. We are a community, and definitely we are going to stay so until we definitely get to realizing all our proposed achievements. So till we come together again on another webinar, have a wonderful weekend, and God bless.
Right, thank you very much. For those of you making an inquiry about slide, we made it very clear at the beginning, the slide will not be available. Even I don't now have the slides, but we have a recording of the webinar that will be made available. If you're not a member of our WhatsApp, just email us. You see the email as there, NSE London UK @gmail.com. Email us and we'll point you to the link on YouTube where the video will be made available by tonight. The moment Zoom process it, it will go on YouTube. So that's all we have to say. Thank you again very much for coming. Albert, wonderful. We have a lot to talk about. I've got I need your number, your home address. You say you live in the East End. I live in Walthamstow too. So we're not far from each other.
We're not far from each other, yeah.
Okay. Thank you very much. Really appreciate you. Thank you.
Thank you very much, everyone.
Yeah.
So Albert, thank you. God bless. Really proud of you. And
thank you, everyone, for listening.
Thank you for your time. Yeah.
Stay safe.
Unfortunately, Albert, before you go.
Hello.
Yeah, sorry, mistakenly I mute everybody. I want you to meet them and I meet them instead. So yeah, that's fine.
Yes, I was just asking, what is your plan to give back to Nigeria? Because this is really more.
Sorry, I didn't hear that.
I said, what is your plan to give back to Nigeria?
He said, what's your plan to give back to Nigeria? In other words, he's saying, are you going to become member of London Branch NSE?
I'm actually saying more than that.
That's what it's at. No, but listen, to get to God, you have to come through Jesus. Yeah, London NSE is Jesus. It comes through us, and then we'll give back to not just to Nigeria, to the whole of Africa.
Well, On a practical level, I am involved in stuff in Nigeria. It's just that I can't talk about it right now. But hopefully in the future, I'll be able to talk about it. I don't have a problem looking at stuff, and I didn't mention some of the my early years and some of the stuff I did in Nigeria, which is to do with helping the areas, really the community in terms of creating some of the structures that allow them to access the site. So I don't have a problem giving in Nigeria. I just feel that at the end of the day, if it's the right kind of project and the right kind of people, and they really do believe in what they're doing, I don't have a problem with it. As AKT, we don't have a problem with it.
Okay.
Okay, thanks for that. One more thing before you go. Hello?
Hello?
Yeah, thanks. One more thing, because I learned you went to Unilag.
No, I didn't.
Okay, I thought I had Unilag.
No.
You're in a different meeting for that. Alba was born and bred London.
Okay. Okay, that's fine.
Right. Thank you, guys. I'm gonna close this conversation now.
Okay.
Please.
Thank you. Bye.
Thank you.
Bye.
Well done, London, again. Fantastic presentations.
My chairman, I didn't know you were in there. Well, thank you very much. My eyes was very busy today. Sorry, I didn't.
I enjoyed our presentation more than you do. As in, it's awesome. No.